Good afternoon, friends of the Liblit Scholarship Committee and Friends of Solid Waste. Welcome to the opening webinar of the fall series of the Larry Swanson Waste on Wednesdays series. Today's presentation, entitled Waste 102, is the first of 5 in a series of consecutive Wednesdays at 12 noon. The series will culminate on Wednesday, November 17th, with the annual Liblit Committee breakfast at the Irish Coffee Pub in East Islip. As of now, it will be a live get-together. See the website for further details. I am Jim Heil, serving as your moderator today. I would like to provide some background on the Liblit Scholarship Committee. The committee was named for Evan Liblit, who was a pioneer in recycling in the early days. He worked for the Environmental Protection Agency, where I first met him, then was drawn to the state to write the recycling plan initially for the state, and then came back to Long Island, was commissioner in the town of Babylon, and worked for a private company thereafter. He passed away early in his life at the age 47, and his colleagues, noting what great work he had done, decided to form a legacy and establish a scholarship committee at Stony Brook University. And from this, the committee was formed and established the scholarship fund and programs to fund the program. This was the initialing of the Liblit breakfast, which was a fundraiser. And then we expanded into educational opportunities, recycling symposiums. And when COVID hit, we evolved this series on Wednesdays under Larry Swanson. Since the scholarship fund has established, we've given 24 scholarships to graduate students and 18 to undergraduate students. And that many have gone on to become leaders in the field of solid waste. Once again, the annual breakfast is scheduled for November 17th, and we would ask your participation so we can continue this great work. So, on with today. Logistics will mute everyone. Questions will follow the 3 presentations. As you see the presentations, any questions can be filed in the chat box on your screen. And at the end, I will try to group them and then ask the particular presenter if there is adequate time left. We will try to keep within the hour time frame. Waste 102, which is the title of today's presentation, will focus on questions on advances and future trends in solid waste management nationwide and in New York State. The first session will address enhanced producer responsibility initiatives in New York State and nationwide. The presenter is Scott Cassell. Scott is the founder and CEO of the Product Stewardship Institute. Scott, excuse me. Scott is a renowned leader in the U.S. product stewardship movement. Scott Cassell has over 35 years of experience tackling waste management issues in the public, private, and nonprofit sectors. He is the founder and CEO of the product of PSI, which brings diverse stakeholders together to research, develop, and implement extended producer responsibility laws. He served as Director of Waste Policy and Planning for the Massachusetts Executive Office of Environmental Affairs and has experience with more than 20 product categories and has been actively involved in the development of numerous state and federal EPR bills. He has a master's degree in environmental policy and dispute resolution from MIT, as well as a bachelor's degree in geology and environmental studies from the University of Pennsylvania. Scott, please proceed.
Thank you very much, Jim. I'm going to share my screen now. And everyone should be able to see that. So thank you. I'm really honored to be here. It was a great introduction, Jim. I appreciated that background. And I think it's extremely important to thank those and recognize those that have come before all of us. We're all building on the past, and we don't do this ourselves. We do this with a lot of help, a lot of colleagues, a lot of support, and a lot of stakeholders. And that is some of what I'm going to be talking about today. So here goes. Our organization, the Product Stewardship Institute, we have been building capacity for product stewardship and extended producer responsibility, or EPR, in the US for the past 20 years. We are based in Boston, but we work nationally. We work quite a bit in New York and all around the country. We also work internationally as well. We have members from 47 state environmental agencies, and you can see those to the left of the screen. It's state and local governments. So you see the New York DEC, New York Department of City Department of Sanitation, and many others that we work with in New York. But we also have over 120 different partners, including Covanta and many others that are operating in New York. So our board of directors, state and local governments, and our partners are businesses, organizations, universities, and international governments. Our mission is to reduce the health and environmental impact from consumer products all across their life cycle. And we work on the entire waste stream. So those of you that are working in waste, you know that waste is a problem. And so we work on all the problems, as many of you do as well. We work on over 25 product categories. So you can see the array that are here, at anything from solar panels and textiles to packaging, batteries, electronics, medical sharps, gas cylinders, carpet, tires, paint, the whole shebang here. And I'm going to be talking about some of them. So let's get into a little definitions. We do have these two terms. Product stewardship is a broader term. As you see the bigger circle, it encompasses both voluntary and regulatory initiatives. Usually we think of manufacturer or producer responsibility as one of the key components of that, but there are also voluntary programs as well that fit into the category of product stewardship. But for EPR, the extended producer responsibility, we use that term for regulatory initiatives, only the standard takebacks that we see for all of the different products that put a requirement on the producers and other stakeholders as well. And here's more of a specific definition. EPR is a law that extends a producer's financial and often managerial responsibility for the products and packaging that they sell onto the marketplace beyond the manufacturing stage. That's beyond the plant in both directions. So upstream for product design and the mining, manufacturing of materials, the design, and then post-consumer to reuse, recycling, and safe disposal. Now, EPR, maybe it's a new term for some, but it was for 20 years ago when we started out, but it is recognized as the centerpiece of what we call the circular economy, trying to return materials back into productive use all along the supply chain. And it is mandated, EPR is mandated as being the centerpiece of the circular economy in Europe. And this is where a lot of these ideas emanate from. Those of you that are studying this right now, I could go back to the history of this over 35 years ago in Europe and into Canada and other places. And we really imported this concept here to the United States over 20 years ago. So this is the trajectory of the EPR laws that have passed since 2000 when we were founded. There were only a few laws, and now there's 124 of them, and you can see the steep increase of those. Now, EPR did start with EPR on one product. It was two products, if you will, primary and rechargeable batteries, single use and rechargeable batteries, in only a handful of states in 2000. But now it's 124 EPR laws on 15 product categories in 33 states and the District of Columbia. You can see where New York is well placed with 5 of these laws. There's the Northeast is very much an uptake of these regulatory strategies, and not surprising. The West Coast as well, and then some in the Midwest also. So here's some of the laws that we're talking about. From the far left, there's packaging. 2 of these laws just passed in 2021. There's mattresses, fluorescent lamps, medical sharps, paint, batteries, thermostats that contain mercury, electronics, and pharmaceuticals. Some you see like pharmaceuticals and medical sharps. There's a number of local laws in addition to some of the state laws as well. The key elements of these programs are: 1, legislation. It levels the playing field for all manufacturers that contribute into the system. It's needed for almost all these different products because it costs more to collect and manage these products than it does, on the value and the sale of any recyclables at the end of the product's life. The second is that producers have a primary responsibility for financing and often managing these systems, taking that burden off of municipalities, off of the taxpayers and ratepayers themselves. There's a stewardship organization. So the manufacturers are required to comply with this law either individually or collectively. And collectively means they can join together in a stewardship organization, which most of them do. Retailers play a very significant role, but they do it voluntarily for the most part. Here, they get people into their stores to collect the materials and to bring them back into the circular economy. There's performance goals. We have to know, hey, are these laws working or not? Well, we have performance goals in these laws and convenience standards to make sure that it's convenient for residents to recycle. And finally, you need to have government oversight. If it's a state, it will be the DEC, that is the oversight agency. I could talk for a much longer time on how we develop policies, but we have a method that we've developed over the past 2 decades for developing all of our policies. And it starts with 16 boxes. We break down the whole concept of whether it's packaging or electronics into, what are the covered materials? Meaning, how do we define the universe of materials in that tagline of packaging? Where are we collecting from, the covered entities? How do we define the convenience, and what are the collection requirements on the producer? How do we define the responsible party or the producer in the first place? What's the governance? How are the different control of which systems, and how does that work? Well, we've done this so long that we understand that there's a recipe for doing it. It's different for each product and it has to be worked out, but we can use this system, and that's how we've developed all of the policies that we have come up with. Now, why is EPR growing? Well, first of all, the ground has been plowed here in the US. People know what this term means, but we also have tremendous experience now. There's sustainable financing. That is the big deficit in all of these programs. It starts in the beginning. It's a sustainable financing system. You get education and infrastructure for collection and recycling. You get the increased recovery as a result of this infrastructure. It's often creating lots of jobs as well. And of course, that rings true for the politicians and others. And it's overall, I consider it a network of accountability. It's not focused only on the producers, but there's an accountability for state and local governments, the collectors, the recyclers, and consumers themselves. So everybody has a responsibility, with the primary focused on the producers themselves. And there's a potential here for making better products, giving incentive, which I'll get into in just a second. So EPR for packaging and paper products, PPP. There's tremendous momentum in the US. We've been working on this for over 15 of our 20 years, but now it's finally broken through. 2 laws have passed this year in Oregon and Maine, the first 2 in the nation. We worked with those 2 states. We were also working with New York and about a dozen other different states to take the model and work with that in those states and to integrate it into the existing solid waste management system in those states. We've also worked federally on the Federal Break Free from Plastic Pollution Act, which has EPR for packaging as its centerpiece, but they're going to be breaking it off this year and having a national bottle bill that will soon be introduced as well as other elements. The first two laws in Maine and Oregon, very similar, they're reimbursement systems. So that means that the systems are relatively the same. They're going to stay the same. The municipalities collect, they have contracts with the collectors and the recyclers, and they get reimbursed for their costs. As you see in Maine, it's up to 100% of those costs. In Oregon, they settled for the processing, which was 28% of the system costs, not the collection. Maine, it's packaging only. On Oregon, it's packaging, food, serviceware, and paper products. Both of them have substantial rulemaking, which means they defer some of the tough decisions to the DEC in a rulemaking process. And in Oregon, they had environmental justice provisions, which is the cutting edge of these type of systems. Both of them have also what we call eco-modulated fees, which is trying to give an incentive to the producers to introduce into the market packaging that costs less to recycle and is better for the environment, meaning has recycled content, fewer or zero toxics, and other aspects. So the amount they pay will depend upon what they put into the system. And here's the EPR laws in New York. As I mentioned, there's 5 of them, early one in 2010 on rechargeable batteries. There's mercury thermostats, electronics, pharmaceuticals, and paint. We have worked on all these different product categories. There's also a refrigerants one in New York City. It's a niche. It's the only one in the country right now, although Washington State is introducing a similar piece of legislation. And then solar panels. We work with Niagara County to just pass the first local ordinance in the country on solar panel EPR legislation, and there will be likely bills at the state level on this as well. So getting down to that, 2021, there's EPR bills in New York on single-use batteries, since there's already one on rechargeables, carpet, an amendment on electronics, and then packaging, as I mentioned before, is really the big one, and then smoke detectors. And those will come up again in 2022 if they don't pass this year, but also there'll be an expansion on batteries to lithium-ion batteries. They're causing lots of fires, big concern there. Solar panels, as I mentioned, mattresses, which we've worked quite a bit on, and all household hazardous waste. Lots of things to focus on. And winding up here, as I mentioned in the beginning, it's so important to work with key stakeholders. This is just a handful of the key stakeholders on any particular product. They need to be aligned, or else there's problem politically. And we take I'm a mediator, so we understand that if you have all these different stakeholders that are at the table in the beginning, working through the system, it'll be much more likely that the producers and the recyclers and the collectors, in addition to everyone else, will be invested in making sure that the law is implemented for success. So that's it for me. Here's some of what we do. We have partnerships, again, for companies, organizations, universities, and international governments. We have membership for state and local governments, and we do lots of consulting for public and private research, pilot projects, facilitation, consensus building, education, and also policy development as well. So feel free to contact me. You'll have all these slides, and I will now hand it back to you, Jim, to go on to our next speaker. And we'll take questions, I understand, at the end. Thank you.
Scott, that was a good presentation. Well done and well presented, and lots of information. And I thank you for that. Our second presenter is Scott Pizzotti. Scott is an engineer with Covanta Energy Systems and has spent 33 years doing waste disposal work and research on waste residues and how to recycle and recover some elements from the ash from waste to energy facilities. He is a professional engineer in New York and New Jersey. And I would like to now present Mr. Basati, Steve, and I've known Steve for a long time and appreciate him joining us tonight. So Scott, it's yours. Steve, it's yours.
Okay, can everybody see my screen?
Yes, I can. So
I know I got to go to the presentation mode. Give me a moment. So thank you, Jim, for the introduction. Certainly, I've been around the business since 1988. Been in a variety of operations, maintenance, executive management roles, and I've been leading the ash and metals business for Covantis since 2011. So I always like to start off the presentation with some pictures and a little bit of an overview. And I appreciate the opportunity to talk about ash. Since 1988, I've been hearing about rollite and a lot of other trials and tribulations related to ash. And I'm happy to say that we're finally moving product to market. And we're very proud of the accomplishment, despite the fact that the last 18 months of startup has been really interesting and challenging. I'll give you the evolution as we walk through this. So on this first slide, you'll see from left to right, really some components of the system. On the left-hand side, it's really the ash wash drum. We introduced the material after dry screening, certain fraction sizes, to the wash process. Second from left is some components related to basically the equivalent of water tables that you might see in a gold mining show, is what we use to get the fine metal out. You see the second picture from the right is fine metal capture. We also refer to that as high value metals. And it really is metal units that are below 12 millimeters. And we literally get it down to components of metal that would fit on the tip of a pen. And then the last thing is just, we did build a roadway with 200 tons at the site as part of our plant development. And we have subsequently signed an offtake agreement with a local asphalt producer. Interesting thing about that asphalt producer, they actually do have a quarry. We originally targeted folks without quarries, thinking they would need us more, but they're very happy with our material. We'll get into that in a few minutes. So just a quick view of Covantis Metals Management. You know, what are we? Really, my responsibilities and overseeing our team really comprise 4 basic categories. I won't read every one of them, but I'll read the headings. Business management and development is really expand our horizons, you know, how to get more metal units at our assets or with our clients. Strategy and marketing efforts. So when I went into this role in 2011, we were only recovering about 400,000 units of metal from our EFW facilities. We're pushing 700,000 this year. So we made a lot of progress. And we shifted from ferrous metals to a lot of non-ferrous metals as well. We went from like 60,000 tons a year to, 10,000 tons a year to over 60,000 tons a year, with a vision to get that to 100,000 tons a year in the next few years. We also have created assets, and some of you visited, and we encourage you all to come visit, to where we take that metal that we extract from the plants and clean it and separate it into different commodities. So we sell 95% copper, brass, etc., and some of you have seen that. We're always looking to get better, so continuous improvement and optimization. We have 3 project engineers, field engineers that visit our sites and provide service and advice on recovering more units. And the last thing is, of course, have to plan is executing on the project. So we execute our own projects within my group. We do the engineering and the execution, and we've executed on about 70 projects in the last 10 years. I like this slide, despite the fact that it's very busy. I'm a pretty organized guy, but this slide in some respects drives me crazy, but it really does tell the story. So the top half of it is, you picture our EFW facility. Sorry, Ed, it should be Hempstead. I know it's Long Island, but I didn't have time to change the slide. So really, the path starts with the top. We take the metal out of the facility, and we bring it, some of it, to Fairless Hills, where we clean it and separate it. And before our group existed, we never sold a ton of metal to a steel mill or a copper smelter. Now we sell a significant amount of our material to steel mills and copper smelters. So that's really just depicts the fact that we've made investments into cleaning our own metal in areas that, we needed to focus on. On the bottom, of course, what's left over is the ash. And, we worked with a technology provider and developed a system that would allow us to, through a combination of dry and wet separation, create very clean products that we can move into the asphalt, concrete, cement industry. And of course, we're still sending material to steel and smelting operations. There is residual material, a little less than 50% still goes to landfill. But we've made great progress, even in the last 3 months at Fairless. I used to slide at a presentation in Europe a few years back, and everybody in this call is probably familiar with the regulatory environment that we face. But the reason why I made this point when I was in Europe is that in Europe, bottom ash and fly ash are separated and kept separate. I would joke with them, I could do ash reuse with 2 hands tied behind my back if it was just bottom ash that I was dealing with. And of course, most of our plants are permitted to mix the bottom and fly together. So we couldn't even demonstrate our material by shipping loads to technology that we've seen in Europe, because they have no way to handle the fly ash components. So we really were hamstrung. So we decided to build our own pilot plant. So really the premise was, okay, bottom ash is used exclusively in Europe. We know the composition of our material. We studied it for about a year. We took samples from 11 facilities over months and months, compared to data, looked at degradation, et cetera. And we decided to get with a mineral mining laboratory in Colorado and make an investment in our own pilot plant, where we would send combined ash to it and demonstrate it. Of course, it was on a smaller scale, but it was to demonstrate that by using water technology, we'd be able to create valuable products out of the material. And of course, without reading every bullet, our findings were, sure, ash contains positive attributes for reuse. Remaining metal content would be a limiting factor, meaning if you don't get the metal out, you're not going to be able to reuse the aggregate. And even the spec today that we deal with has a very low tolerance for aluminum when you look at the state specification of Pennsylvania. The remaining fines would require innovative technology to recover and remove it. That's the metal. And then wet screening and separation would improve results. There's been many folks that have tried to do dry screening and separation and have not been able to meet a specification for reuse. There's opportunities for that, of course, but you're not going to go into asphalt or cement or concrete production. So really the results we're very happy with. We demonstrated that we can do it, and we passed all non-haz leaching tests for all the products that came out of it. And we said, you know what, let's make our first investment. Let's scale this thing up and see what we run into. When we did the pilot, we took ash from 7 plants and 4 different combustion technologies, but we never really got a chance to run, hundreds of tons. We ran loads, 20 tons plus at a time out of each plant. This pie chart gives you an idea of what remains, or where we would focus our attention, what we wanted to get out of that ash. And mind you, this is after we made over $100 million in investments at our energy from waste plants to recover all those additional metal units. There was still an opportunity to get more iron, non-ferrous, low-grade ferrous. That's something we refer to as very low grade. You need high intensity magnets. Kevin can talk a lot about that, how to get that out, but certainly it's there and it's available. And then we learned about metal concentrates, really small fractions of very high valuable metals that we call metal concentrates. And lastly, we had the aggregate opportunity, and that was comprised of three components: sand, large aggregate, or what we would call coarse aggregate, and medium aggregate. Now, this is the results coming out of the pilot plant, and we looked at moving and tested moving this material to the different feedstocks and products that you see on the right. Meaning the low-grade ferrous is like an iron ore source that cement kilns have to bring in to make their clinker, that ultimately turns into the ready mix that we all use around our homes. The medium aggregate would go into concrete, and the rest of the material would go into asphalt. So why do we choose Pennsylvania? I'm a Queens and Long Island guy, and I wound up in Pennsylvania driving here every day. Why Pennsylvania? Well, Pennsylvania actually stepped up. They published what's called GP 61, and they provided a regulatory pathway to create aggregate products from energy from waste ash. That's why we started in Pennsylvania. Of course, it's convenient that we have two other operations here, you know, ferrous processing plant, and all the non-ferrous we recover in the company comes here. But really the main driver was the permit. The state of Pennsylvania created that regulatory pathway, and I see that as a limiting factor for us to be able to go do this in New York. We have to create a regulatory framework that would allow us to make products out of the ash. So part of the, you know, expectations of that permit is we test for 22 inorganic constituents and 41 organic constituents. So we literally take daily samples. We got to test daily up to 1,000-ton lots, up to 10,000, and then beyond. And but they created a hierarchy, and there's three areas that you can reuse material. The most stringent leachable limits means no attenuating soil. You could use it like you'd use gravel. You don't need any buffer. The second one is you do need that buffer. And the last one is there's no attenuating soil needed, and really tight concentration limits of the 63 parameters that I mentioned earlier. This is very easy to find, and my email is at the end. We can send you a copy of GP 61, but very easily you could find it on the internet. The last thing, and where we've tended to focus, because I talked about cement, concrete, and asphalt, we really spent the majority of our time focused on moving material to asphalt. My philosophy was that asphalt plants are a dime a dozen. They're everywhere that we operate. Cement kilns aren't necessarily in our backyard. So if we can make a good product, then we should be able to move it on a regular basis to asphalt. So it would not be considered a waste or aggregate if it was encapsulated when you meet the criteria here. So you got to meet the leachable limits under items 1 and 2. And you got to, the asphalt or concrete produced using aggregate. Well, that's redundant, I just noticed. Leachable limits is in there twice. And then we got to compare the TCLP or the SPLP of asphalt and concrete produced with our aggregate that would otherwise be used in a control sample. So basically looking at our material and make a control sample out of how they would normally make it, look at our material and compare the results. They've been extremely favorable. So what's so special about our technology? And how have we modified it from even when some of you have visited, you know, sometime last year? We use a unique combination of conventional dry separation technology and wet advanced mining technologies to recover fractions of metal. And we're now achieving a 50% reuse. And why do we use a concentration of dry and wet? Initially, we were going wet with all the material, and we found that we are processing up to 40% of the material for very little gain and very little metal content. It wasn't resulting in a reuse of material, and there was very little metal content. So we made changes to the plant that will allow us to screen out certain fraction sizes, still having a non-hazardous disposal, and everything else that went to the wet plant or goes to the wet plant today results in a reuse. So some of the things that we've, products that we're producing, you see the pictures here, And the first one is the biggest surprise, because we made a big effort at our plants to recover more and more ferrous through the years. Some of our average fleet is like 14% of the ash is coming out as ferrous metals. We're actually getting several percentage points more at ferrous. We have 3 different spots where we recover ferrous. It's really, that was the one that probably surprised me the most. We have 3 additional grades of non-ferrous metals. So even at plants that have 2 and 3 eddy current separators, we're doubling the recovery when that ash comes to ferrous hills. The high value metals concentrate that you see in the lower left-hand picture is largely copper based. That goes directly to copper smelters, and it has fairly high PM content. You get paid for silver and gold, so it's very interesting. And we're able to recover down to literally millimeter sized components. There's not a high percentage of the ash that comes in with that, but it's highly valuable. And frankly, it's an interference with being able to use the aggregate in a reuse, because our criteria is all about not having metals in it. And the last thing is we're currently creating 2 grades of aggregate, essentially sand and stone. We're making a product that we would refer to as fines, and like what we would call the mids, a smaller fraction of pebble aggregate. And the result is waste. The waste that remains is just fine combined ash, because we screen that out up front, and then filter cake. So whatever material gets carried through, that winds up becoming a total suspended solid in the water system, will be pressed out with plate presses, and that results in a filter cake. So you see some of the pictures here. You got the high value metals, the fine non-ferrous metals in the middle, and then that goes to processing at our non-ferrous plant next door, as does the large non-ferrous, where we separate through density heavy and light metals for resale. The physical property evaluations we've done we have several universities. We didn't list them, but we've been working with several different universities on a variety of testing. We don't have everybody doing the same thing. We're dividing and conquering, because we're trying to get both an asphalt, cement, and concrete. The 4 material properties that we target are gradation, clearly the most important, specific gravity, bulk specific gravity, and then absorption and unit weight. So we'll talk about absorption just in a little bit more detail. When you go into asphalt, right, the most expensive part of making asphalt is the tar or the binder. If your absorption is above 4%, and frankly, we're down to like 1%, it will cost more to make that asphalt. It's hard to convince anybody to take your product if it's going to cost them more to make, So we're doing extremely well in our absorption, and frankly, our asphalt producer and our aggregate purchaser, which are one and the same, are asking for more material. They want more of the fines even in the material. So we've been very successful. Our products are used in commercial and residential asphalt applications every day. We're closing in on 10,000 tons moved to market. And we expect that in the new year to be above 5,000 tons a month. See some pictures of the mids aggregate up in the upper right. And you can see it, the pile in the larger picture. It gives you an idea. It's hard to believe when I showed you the picture earlier, the European one I spoke of, that this came out of ash. It really is a beautiful material. So, I talked about our asphalt mix designs, and it's a partial aggregate replacement. And, the one particular university in New Jersey was pretty renowned for their study of asphalt mixes. So on the asphalt side, we've worked closely with them. And we're very happy that we've met our volumetric and mix performance testing have both met DOT requirements. And we've paved the roadway here as our first step, because we had to do that project anyway to be able to bring trucks into our facility. So it's nothing like using our own material and demonstrate it. And the core samples are as beautiful as virgin material that would have been used. And that also led the asphalt company to want to enter into a long-term purchase agreement. So again, we sell our aggregates to market weekly. Other areas that we're looking at, and that truthfully, at this facility, they've become a little less important because while we want to thoroughly understand, and we're still researching cement and ready mix, at this facility, everything we make is going into asphalt. So of course, we're still working on low strength substitutes and non-structural applications on ready mix concrete and partial aggregate replacement. On the cement side, I talked about that irony material, irony, not like irony like ironic, but irony like low-grade ferrous in an ore-like percentage. And the cement kilns are extremely interested. We're moving some material in Florida that we do dry, and we've demonstrated with Hempstead material in Pennsylvania. It's just we need to be closer for it to be economically viable. We've proven that it's technically viable. So some plants may lead to better diversity of outlets than others, but we're quite happy with our material here going into asphalt. I don't want to forget about our mobile capabilities. We bought 2 mobile plants. We designed and had them built in Germany, and we could set up on less than 2 acres mobile units that will process our combined ash and create dry aggregates for reuse. Now, it's not the same quality. It's not going to meet the specifications where we would be comfortable saying, let's go into the residential asphalt application. But I will tell you, it's perfect for shaping and grading, particularly at landfills, MSC berm walls, drainage layers, and road base. And I've been eager to get one of these mobile plants in Long Island operating. Some of you on the call definitely know that's true, because we can demonstrate it. And there's one added feature that we've learned at TAPS that I think we can put in front of our mobile plant and really make a pretty darn good aggregate grade. But I stand behind, it has to be wet and washed to go into asphalt. But we can make a nice product that would be reused and supplant maybe other materials that are brought in to shape and grade and do the items that are listed here. So I'll pause for questions. Well, I guess we're taking questions at the end, but you see my email address here, and certainly we've come a long way in the last 10 years. We've doubled down on metal recovery, and we're really on the cusp of greatness for reusing our ash. We're averaging about 50% today, and I believe we'll be at 5,000 tons a month within 90 days. Thanks for your time.
Steve, thank you very much. Excellent presentation, and look forward to perhaps seeing a facility on the island, permanent one.
Me too.
Okay. Our next presenter is Professor David Tonjes from Stony Brook University. David is the director of the Waste Data and Analysts Center and a research associate with 30 years worth of experience in solid waste. And some of those years have been with me. So it's a pleasure that I introduced David. I think most of the people in the audience know him, but it's always a pleasure to work with David. David, it's yours.
Thank you, Jim. Excuse me if my teeth chatter. Stony Brook hasn't turned on the heat yet, but they've kept the AC on, so it's a little chilly here. I'm going to talk about waste generation patterns on Long Island in the past and perhaps how they project into the future. So I want to tell you a little bit about our research group here at Stony Brook. We've got a group of about 9 people right now, and we're going to have we're going to be 15 in the summer when we do our sampling. My co-director is Elizabeth Hewitt. Krista Thyberg is our associate director. We have a little bit under $1 million in research funding right now. Just to give you a little bit of background about the Department of Technology and Society, which I'm a member of. It's part of the College of Engineering and Applied Sciences here at Stony Brook. And I just want to remind you that the State University of New York is actually the largest university in the world, with 1.3 million students, 64 campuses, and so we're proud of ourselves. Here at the Department of Technology and Society, we give a BS degree in Technological Systems Management, a master's degree in Technological Systems Management with concentrations in technology management, educational technology, and energy policy and technology. And we have a PhD in technology policy and innovation. So when we try to talk about waste trends, it's a difficult process, because the way programs work generally define the scope of their numbers and the way their things work. So it's difficult to compare across programs. Here on Long Island, for instance, the town of Smithtown manages all of its residential and commercial MSW. One of Smithtown's close neighbors is the town of Southampton, which only handles drop-off materials in town sold bags. And so if you compare the scope of these 2 programs, the rate at which they generate garbage, the way their associated recycling rates, they're very, very different in nature. And so it's tough to do a comparison across these things, across particular programs. It's also true if you look across the country. So in 2017, the Environmental Research and Education Fund did a report on solid waste generation across the United States. They went to individual facilities to get data. They accounted for exports and imports. But yet, if you look at a range of states that are relatively close together, you can see that, it ranges from 4.9 pounds per day in New Mexico to 10.8 pounds per day in Colorado. And so the variability across programs, across states that aggregate data is large. And so what we've thought about is you should look at a single program and see if you can draw some conclusions from that. With a single program, you generally have consistent rules, consistent operations. Whether your findings are applicable in a wider sense can be questioned, but we think comparisons are possible. What we're going to talk about here today is mostly the town of Brookhaven, based upon 35 different waste districts within the town. So we get repetition thereby in our statistics. I just want to go back and talk a little bit about Long Island waste management trends. When I met Jim, that was something that Larry Swanson had me doing here at Stony Brook, was generating some data on Long Island solid waste generation, and we generally have thought that in the mid 80s, Long Island was generating somewhere around 3 million tons per year, and that by the mid 2000s that had risen to about 3.8 million tons or so. If you look at the town data alone, that was only about 2.4 million tons, and so Mike Engelman, when he presented last spring, talked about a similar generation rate, but he was basing his data on EPA waste generation data. I don't think that's real good basis, because if you just look at what we estimate at what's incinerated and what's recycled, you're going to get close to 2.4 million tons. I'm going to try to present some data here, which is going to suggest that waste generation has fallen from its peak of about 3.8 million down to maybe 3 million tons a year. That would be about 5.8 pounds per person per day. That's still above the latest EPA data point, which is about 5.5 pounds per person per day, which would translate to 2.6 million tons here on the island. A little background on the town of Brookhaven that I'm going to generate my information on. It is the home of Stony Brook. That's one reason why we like to study it. It's the largest town in New York State by area. It was chartered in 1655. And as you can see from the population graph, it was a relatively small in terms of population, about 25,000 people as late as 1930. And of course now it's about 20 times that size at 500,000 people, due to large, mostly post 1950, 1960s era suburban expansion. The town of Brookhaven has a comprehensive waste management program, but the town itself only collects waste from residential, from residents, no villages, no apartments, no condos, no co-ops. So it's about 3/4 of the population is served by the town program. That's 120,000 individual residences. They collect solid waste twice a week, or at least for disposal twice a week. There's alternating collection of recyclables, paper 1 week, containers the next week, and 21 times a year they collect yard waste. One thing that's makes us feel like we're getting all of the waste that's generated by these 120,000 residences is the town has a 0 tip fee, which means there's no incentive for carters to bring their waste anywhere else. And the use of distinctive trucks painted with the town of Brookhaven sign means that it's difficult to use those trucks outside of the town. So we think it's only town waste that's being collected under the program. I want to talk about daily waste generation trends to start with. What we did was we collected all of the town's 2018 daily waste management data across the 35 waste districts. We took out the holiday weeks because of there would be missed collection days in most of the districts in those weeks. We created rates by using the days between each day of collection, either 3 days for a Thursday, Friday collection, or 4 days for a Monday, Tuesday collection, and applied the number of households in East Waste District. And then what we did was we looked at the Monday, Tuesday collections compared to the Thursday, Friday collections. Because we had daily data, it should be a 1-to-1 ratio of what's collected on Monday and Tuesday compared to Thursday and Friday. But everyone who has worked in the waste industry knows that weekend trash is always heavier than weekday trash. And that's exactly what we found. We found that these ratios in each one of the 35 waste districts was much greater than 1, and was significant for all of the districts except for districts 3 and 33. When I say significant, I mean the difference between a ratio of 1 and the actual ratio in the districts. There was 1 week where we were pretty sure it had snowed and affected the collection of waste. So for instance, and so in District 33, there was reduced collection in that week on the Monday, Tuesday, and the same was true for District 3. And so District 33 was significant if we removed that week, and District 3 was significant for if we just assumed that the waste on Monday and Tuesday was heavier than waste on Thursday and Friday. If we look at the individual weeks of the year, again, so the holiday weeks were taken out. It's significant for most of the weeks of the year, and the weeks of the year where it didn't occur. One, for instance, I already said to you, week 11 was probably a snow day because there was 7 Monday or Tuesday collections where absolutely no waste was collected. We think sometimes it rained a little bit more, and so on weeks 14, 27, and 37, the waste was about 10 to 15% heavier on the Thursday, Friday collection than the Monday, Tuesday collection. And sometimes the waste was sort of anomalously lighter on Monday and Tuesday. It didn't seem to be any good reason for that, but so maybe fewer trucks went out those weeks. There's a seasonal trend. So you can, if you look at these patterns, the first dot represented from each waste district represents winter collection, that is January through March. And January through March is visually different than the other seasons, but it was only statistically different for 10 of the 35 districts. And so there's a sort of a mild seasonal difference in waste generation across the town. However, geographically, this is what's called a heat map. And so what the blue colors represent is we compared all of the district's annual, weekly average of MSW across the year to each of the other 34 districts. And if there was a statistically significant result, the color is going to be in blue. If it wasn't significant, it'll be colored red. You'd expect to have, because statistical significance is a 5% probability, you'd expect to find 30 significant results in these 595 comparisons, but the actual number was 281, and so that the chance of that occurring is relatively low. So what that shows is there's a difference between the individual districts, one to the other, much greater than you would expect if it occurred solely by chance. And this geographic difference can be mapped. So we classified the areas that were north of 25A as being in the north. We classified everything that was south of the Long Island Expressway as being in the south of the town, and the other districts were in the middle. And the north districts were significantly different from the south districts, but not nearly so, but not significantly different from the middle, and the middle and the south were not very different. We'd like to fiddle with this statistical analysis a little bit to see if we can refine it, but so there is an overall geographic trend to the data as well. Now, when we look at annual tonnages collected, the town started with its waste districts in 1989, and so I've mapped here data from 1990 through 2020. You can see that the waste generation rate was variable through 1998 when the town put in its zero tip fee program, and then it's been a lot more consistent. If I'd like to focus your attention on perhaps the one of the recent peak year, which was 2004, when the town had its greatest waste generation rate, except for 2001. And if you look at the trend from 2004 to 2017, it decreased by 26%. And that's a significantly different from being flat. So that's a significant result. This is on a per household per day rate. If you look at the overall tonnages, they decreased by 22%. If we extend that out to 2020, in other words, covering the pandemic and the change in the town's recycling program where they dropped glass recycling, the difference is only a 7% decrease, but it's still a decreasing trend. So overall, I'd like to point out to you that waste generations in the town of Brookhaven, which we think will hold when you look at other localities well. So they vary on a daily basis. That the amount of waste generated over a weekend is different than that generated on a weekday. There's some seasonal variations, but there's changes in waste generation on average across short distances between waste districts, and that there's been an annual trend where there was a general decrease in waste. The pandemic has caused a difference in that because it's changed the way people spend their time. This data is relatively clean and so should be generalizable. Now, why was there this 26% waste decrease from 2004 to 2017? You know, clearly government has been interested, and it's been a New York State priority to reduce waste. There's been various legislation, mostly at the local level, to ban yard waste. The town of Brookhaven, for instance, put that in. There's been various materials bans, and Scott laid out that there's been extended producer responsibility acts which have been intended to change the waste stream and its composition and how it's managed. There's been extensive education and outreach programs to waste generators to try to reduce waste, and people are working with manufacturers to change how they make things and produce things so as to result in less waste. But I'm not sure that those have made a change. You know, for instance, if we look at yard waste for the town of Brookhaven, it's about 15% of the total waste stream. And so if you had a substantial change in yard waste disposal, it would be reflected in the disposal tonnages. But Brookhaven put in its grass clipping ban well before the decline in disposed waste started in 2004, and instituted its separate yard waste collection in 1998. And the 2004 to 2017 yard waste collection trend is actually slightly negative. So that can't be the cause. We think what the reason that waste has declined so much is the phone and the smartphone, because the smartphone has essentially eliminated the daily newspaper and has strongly affected the printed paper industry. We don't print things out anymore. If you look at the trend of paper recyclables collection in the town, which isn't the same thing as waste disposal, I know, but it's an illustration of what's available to residents to put out. The paper recycling has declined by 41% since 2004 through 2020. And this includes the fact that there's a lot more corrugated cardboard being set out. So if you look at the amount of newspaper and printed paper that's being recycled, it's fallen extraordinarily since 2004. On the other hand, it's not just a decline in the town's recycling program, because the containers collection increased slightly from 2004 to 2013. So that's not the reason for the overall decline in paper recycling. And there's other factors that go in. We see product substitution. So plastics have replaced glass and metals. If you look at although overall packaging may have increased slightly, the amount of products that are being packaged when you switch to plastic is a lot more, because plastic has a lot lower ratio of the packaging material to the product than aluminum, steel, or glass. And plastics itself have been lightweighted. We know that from water bottles, which have become incredibly flimsy nowadays. But you also get replacement of rigid plastics with more film and brick-like things. Now, these changes in packaging, the switch to plastic in packaging, and the loss of paper as a commodity in our lives, were not things that were legislated, but actually these came out of social changes and economic changes by manufacturers to move to cheaper packaging methodologies. So it's although governments have been working hard to reduce the waste stream, it's not clear that the most impactful changes have come from legislation or government action, but actually from broader societal changes. I'd like to thank the town of Brookhaven for its assistance in this research. They've been supporting me in one way or another for about 30 years, and their freedom to their ability to share data with me has really been helpful. I also need to acknowledge that Furman Shaw did almost all of the statistical work, and Manuel Corona did a lot of the data entry. Sorry for running long on you, but I hope you've been able to stick around.
David, thank you, both for the data and for your comments on it. So I think that's great insight. And Adrian has just, Esposito has just Chad brought us societal things equals environmental changes. So I think we have to perhaps forego questions. Maybe we can get the questions sent to the appropriate speaker, and they can respond directly to the people. Most of it involved Niagara questions about solar panels recycling. So if anybody wants, if Scott wants to say something about that thing as to what, how is that working? Perhaps you could just say a few comments broadly on that. Can you, Scott?
Sure, Jim, I'll keep it brief here. I did put the ordinance into the chat for people that want it. And we have more information for those that are interested in the legislation and how we've done it. But in essence, it operates very much like any other extended producer responsibility law. The producers of the solar panels, those who sell the solar panels into New York, whether it's direct or through a distributor, they would be responsible for financing the end-of-life management, meaning the collection, the refurbishment of them, if that's possible, and the recycling of them. They also would be involved in managing those in the sense of putting a plan together. We call a stewardship plan that is developed by the group of producers, submitted to the state oversight agency, which would be, well, in this case, would be Niagara County. So they would be responsible as the state oversight agency, the county itself on a state level, which is really what we're looking to do here. And there's a senator and an assembly member that are interested in introducing that legislation right now. We're working with, they've contacted us. So at the state level is really where we're looking. It would operate the same way. A plan submitted, this case, Niagara County or the DEC, for how to set up the collection of these and the end-of-life management. So that in essence is how it operates. There's performance goals. It has to be convenient for those who are de-installing these or decommissioning these. There's education and outreach to the appropriate parties. It's different than packaging, of course, or paint. These are installed, but many will be installed in households or communities. in addition to large solar farms. And that's why it became an issue in Niagara County. They're concerned with getting stuck with the decommissioned panels and the history that the county has in hazardous materials and Love Canal and very in very dark past in terms of environmental pollution.
That was great comments. Thank you. I'd like to, since of the time is we're 15 minutes into overtime. So I'd like to essentially end the thing. Thank our three speakers. Next week is environmental justice on Wednesday at noon. And I thank you all, and you're very good presenters and appreciate it. And on behalf of the Liblit Foundation, thank you all. We'll end at this point. Thank you.
Thank you, Jim.